Okay, so doing number 11, which asks us to compare the densities of the moon and the Earth. And the problem gives us that free fall acceleration on the moon is 1/6 of that on the Earth, and the radius of the moon is 1/4 that of the Earth. So we're going to start by finding free fall acceleration on the moon, which is going to be gm of the moon over r of the moon squared. And then we know that mass equals density times volume. So we can put density of the moon times volume of the moon here. And then the moon is a sphere, so to find the volume of the moon, you do 4/3 pi radius of the moon cubed. And then you do some simplifying, and then you get g times the density of the moon times 4/3 pi radius of the moon. All right, now we're going to do the same thing for Earth. So this is new. Okay, so this is for the Earth. We're going to do the same thing. So gm of the Earth over r of the Earth squared equals, we're going to change mass into density times volume. So g times density of Earth times 4/3 pi r of the Earth cubed over r of the Earth squared. Do some simplifying, and then you'll get g times density of the Earth times 4/3 pi times the radius of the Earth. All right, and then what I did was I solved for density of the moon and then Earth of the moon. So if you do some basic algebra and just get density alone, divide both sides by g 4/3 pi rm, you'll get density of the moon equals g over g 4/3 pi radius of the moon. And then here you'll get density of the Earth equals g over g times 4/3 pi radius of the Earth. And then so what the problem wants you to compare the density of the moon and density of the Earth in a ratio. So we're just going to put density of the moon over density of the Earth in a fraction. So move this here. This is density of the moon, and then okay, so this is our ratio, and then I'm gonna use these things that they gave us in the problem to plug it in there. So I'm gonna put, for gm, I'm gonna put 1/6 E, and then for rm, I'm gonna put 1/4 RE. And then if you do some algebra, some simplifying, like these cancel out, all a bunch of stuff cancels out, then you'll get 2/3. So the ratio is 2 to 3.